Hello and welcome to my video on the Fundamental Theorem of Algebra. Please forgive me if I stumble over my words or if I'm low energy or something. It's quite late here. um, but a couple of caveats. Firstly, from now on I will refer to the Fundamental Theorem as the FTA, just for brevity, because saying the Fundamental Theorem of Algebra like 50 times is not something which I want. So let's begin. The FTA is, the name suggests, a fundamental theorem in algebra, and so obviously has applications in many fields, but those fields specifically have to be with regards to the analysis of complex valued polynomials. For instance, complex analysis, or Galois theory, or, for our interests, um, algebraic geometry. What is important about the fundamental theorem of algebra with regards to algebraic geometry is it represents the first view into the translation between algebraic objects and geometric objects. Now, I will give you some more examples. So this is from Ravi Vakil's recent book. However, what I mean by this is that the fundamental theorem of algebra provides for us um, a bijective correspondence, but it provides for us a correspondence between lists of lists with repeats, so I'm not saying sets, of complex numbers and complex valued polynomials. So um, for any list, you can very easily make a complex valued polynomial, but can you make a list of complex numbers from any complex valued polynomial? And the FTA says yes. So here is one example, but a few more in the form of a list, just because I couldn't give the visualization for all of these, because then that would be silly. Um, but uh, I think it is, well, I think I should probably talk about uh, one or two things. So firstly, algebraic geometry, you're what you're doing, especially in classical algebraic geometry, is answering questions about one discipline using intuitions from another. So, for instance, a polynomial a real valued polynomial with complex roots will always have the complex conjugate of any one of its complex roots. So you have a horrific, awful, complex function. If you multiply by the conjugate of all of its roots, then you have a much nicer looking complex, a much nicer looking polynomial function because you've taken away all of the complex coefficients. And then in much the same manner, you can multiply by the most common multiple of all of its denominators to get a integer valued polynomial function if it's, well, if it's rational. If it's irrational, good luck. But yes, I think we should move on and actually discuss the statement. I have one more caveat, but that list comes back up. So this is the statement as it was in my lecture notes, in my complex analysis lecture notes. We proved it using Liouville's theorem, but we're not proving it in this video, otherwise it would take maybe 30 or 40 minutes. But this is the statement as it was. It's the most useless of the three versions of the FTA that we're going to come up with, so I think we should very quickly talk about the next one, where the only difference between the two is that you've replaced every polynomial has a complex root. Oh, non-constant, non-zero. Has a complex root with has exactly r complex roots. And that statement, together with this lemma, where if a complex polynomial has a root, then you can pull out that root as a linear factor um, in this sort of a manner. Well, you can pull that linear factor out and just keep doing that until you have R linear factors representing the R roots of that polynomial. Well, that is getting a list of R complex numbers from a degree R complex polynomial, which is the other direction. So we have shown that there is a bijective correspondence with what are called multisets of complex numbers and polynomials. And obviously where this is non-zero and all of these are zero, what in fact, I can discuss that in a second. So, returning to our list, we talk about the thing which I wanted to talk about, which is if we look here, all of these are approximations. So, the FTA does guarantee that we will get some list, and indeed that list will be as long as this number here. However, it does not say that we can write down all of the numbers in that list in a nice way. So this is an insoluble quintic, as uh, a lot of people who've taken Galois theory can tell you. It cannot be written nicely in terms of square roots, cube roots, fourth roots, etc., etc., etc. There is a way of writing it nicely using hypergeometric functions, but uh, I will let Wolfram Alpha do that. It's simple enough to type it in, so enjoy if you really want. But yeah, these are these are approximations, and indeed, uh, every single one of our polynomial functions may be rewritten in terms of linear factors, and these repeats become uh, multi multiple repeated powers, I guess, or higher power versions. So we can move on to uh, a looking forward, which is using more mathsy symbols. This is what the FTA says, and using uh, our looking forward skills, which is again Vakil, we can see that our complex valued polynomials, where we're talking about them all scaled down, so think monic if you really want. So the leading term is a 1, complex valued polynomials. Uh, correspond exactly to lists of complex numbers, but these also correspond exactly to the effective they divisors, and yeah, that's how you pronounce they. He is French. Um, or there is a more French way of pronouncing it, but I am not French. They, probably, of the spectrum of C adjoint X, uh, which is the univariate complex polynomials. Now, that looks very scary, but if we return to our previous list, x to the 4 minus 3x cubed corresponds to 0, 0, 0, 3. So 3 sets of zeros plus 3, 3 zeros plus 3. This is the effective divisors are a way of, uh, well, a way of generalizing what we mean by polynomials corresponding to points. They are a way. In fact, they are the correct way in terms of the fundamental theorem of algebra, because if we're talking about the Nullstellensatz, which we will do next time, um, we're kind of killing off the multiplicities somehow. So x to the 4 minus 3x cubed would kill off the multiplicities and we would just get x minus 0, x minus 3. And we don't necessarily want to do that. But I think that is as good a place as any to finish off. I have done this video as a sort of experiment. Firstly, I've gone off script, but I have written somewhat of a script for this video. And secondly, I've tried not to draw that much. I've used this, but I've not really drawn. I don't like scripting things. I find it boring. I have it physically written down. I don't know if you can hear, but I'm moving around the paper. And that's everything I think I need to say or want to say. These last couple of weeks well, the first bit I took a break and the second bit other responsibilities took over, but I will try to continue with a semi-regular schedule. I've tried to get an easy one, um, an easy video to lean me into it, but it's nearing 4:30 in the morning, and easy is not in anyone's dictionary at that time. So hopefully this is good, and as ever, my lovely, lovely fiance is to be credited for drawing this funny bird, I think she called it, or cool bird. But yes, goodbye.